You will sometimes come across situations where a factor that you want to analyse can't be changed as easily as your other factors. For example, you might have no difficulty spreading different amounts of fertiliser over small plots, but can sow your plant varieties only over larger areas. The solution proposed by a split plot design is to sow the plant varieties in the large areas, then split these large areas into smaller plots and apply different fertiliser amounts to these. The following experiment assesses the effect on yield of 3 oat varieties with 4 levels of nitrogen application. In the split plot design shown here, the treatments are the 3 varieties of oats: Victory, Golden Rain and Marvellous, and the 4 application levels of nitrogen fertiliser: 0, 0.2, 0.4 and 0.6 hundredweight per acre. As it is easier to work with smaller plots for fertiliser than for varieties, the 6 blocks were initially split into 3 whole plots, and then each whole plot was split into 4 subplots. The varieties were randomly allocated to the whole plots within each block, and the nitrogen levels were randomly allocated to the subplots within each whole plot. A standard analysis of these data recognises the 2 basic elements inherent in the experiment. One is the stratification of the experimental units into blocks, whole plots and subplots, and 2 is the treatment structure that is superimposed on the experimental units. The aim of the analysis is to examine the importance of the treatment effects while accounting for the stratification and restricted randomization of the treatments to the experimental units. I'll demonstrate how this analysis can be carried out using ASReml-R. I'm going to use RStudio, but the commands will be the same if you're using a different interface. Load the ASReml package. Then load the oats dataset, which is an internal dataset in the ASReml package. We can display the oats dataset using the View function. This displays our data in a spreadsheet-like data viewer. We can also investigate the dataset structure using the str function. The blocks, wplots and subplots factors describe the split plot stratification or experiment design. The nitrogen and variety factors describe the treatments, and yield is the response variate of the experiment. The ASReml-R command for fitting a linear mixed model is ASReml. The model itself is specified using the fixed, random and residual arguments of ASReml. You can find detailed documentation on the ASReml command in the help. The split plot analysis is achieved by fitting a linear mixed model with blocks and wplots within blocks as random effects, and variety, nitrogen and their interaction as fixed effects. Both the random and fixed terms in the model are specified as a formula, with the plus operator separating the terms in the formula. In addition, in the fixed formula, the response variate is specified on the left of the tilde operator. The residual or error component of the model is specified in a formula through the residual argument. The default is a simple error term representing independent and identically distributed effects. As this is the case with the split plot analysis, we do not need to specify the residual. Let's run the split plot analysis and save the results in an object called oats.asr. The data argument of ASReml identifies the data frame containing the variables. During model fitting, the iteration sequence of REML log likelihood values appears in the console. Here's the log likelihood value at completion of the ASReml call. Before we examine the parameter estimates, let's inspect the residuals. If the residual assumptions of normality, constant variance and independence are met, then the histogram should resemble a normal distribution. The quantile plot should be approximately a straight line. The vertical spread of the residual should be even across the range of fitted values, and there should be no trends or patterns related to unit numbers. These criteria appear to be adequately satisfied here. A summary of the estimated variance components is given by the following command. The fixed and random effects are given by the following. A table of incremental Wald F-tests for testing the significance of the fixed effects are obtained using the Wald function, with the den-df argument set to default. The table contains the numerator degrees of freedom, the denominator degrees of freedom, the incremental Wald F statistics, and the probability value. The tests are sequential, meaning they are conditional on the order the terms were nominated in the model. For example, the test for nitrogen represents the effect of adding nitrogen to the fixed model containing both the intercept and variety. Predicted means can be obtained using the predict function. For example, the predicted nitrogen means, with standard errors of the differences, are obtained using the following command. oats_n.pv contains three components: p-vals, SED, and AV-SED. P-vals contains the predicted means. SED contains the full matrix of SEDs. AV-SED contains the minimum, mean, and maximum SED. For more information, please read the ASReml-R reference manual, which you can download from our knowledge base. Section 7.2 provides a complete walkthrough of the example used in this video and explains the entire analysis in much more detail.